Newton's method is an algorithm that can be used to approximate the roots of a real-valued function f. In this video, I want to recap the theory behind the method and show you an animation on how it really works. The method consists of the following 4 steps. At first, you have to choose an initial guess, which we are going to call x0. Next, you will then have to know both your function f and its derivative, which we are going to denote by f prime. You are then in a position to use the main formula, or really the iteration formula, of Newton's method. You can calculate the new x value by xk plus 1 is given as xk minus your function evaluated at xk divided by the derivative evaluated at xk. This step can be repeated until the change in x becomes sufficiently small or until you have approximately reached your root. Note, however, that in this method convergence is not guaranteed and it relies heavily on the initial value that you choose in the beginning. Now, what is the idea behind Newton's method? Well, the idea is pretty simple. Essentially, we just want to approximate the function f of x by the tangent line at the current position. So we can write y equals f of x sub n plus f prime of x sub n times x minus x sub n. So this is essentially just a first order Taylor expansion. We then want to figure out where this tangent line crosses the x-axis. So we set y to be 0. We can then solve this equation for x, which gives us exactly the iteration step we saw before. So in conclusion, the main point of Newton's method is that by finding the 0 crossings of the tangent lines, we can get increasingly closer to the root of our actual function. Let me now show you a visual example on how the method works. To do that, consider the function given by f of x is equal to x plus 6 times x plus 3 times x minus 3 times x minus 6 and all that divided by 300. We can pretty easily read off the roots of this function right away, but let's try to solve them with Newton's method. We first need to choose an initial guess, which I have denoted with the red dot and marked by x0 here. Now, remember the iteration step we saw before. Let's see what happens if we apply one step of the iteration to our initial value. At first, we seem to be moving away from the root, but as you can see, already after the third step of the iteration, we are almost perfectly on the root. I hope you found this video helpful, and I would be really happy about a like or a subscription. Let me know if you have any topic suggestions for next videos. Thank you very much for watching.